Okay, so a scientist here records the velocity of a particle, right, in a 9-second period. So you can see the velocity here increasing. So in other words, the speed's increasing here, and then he sort of levels out a bit. Okay, so there's still increase a little bit. Then the velocity or the speed starts to fall, right? It starts to reduce down until it stops. Okay. Now here it says use the graph to estimate the acceleration when t is 1.5 here. This acceleration is looking at how velocity is changing. Okay, so steeper the curve, okay, velocity then is changing rapidly. Okay, in other words, speed is increasing over a short period of time. Okay, so it's getting faster and faster. Okay, but here then as it sort of levels out a bit, velocity isn't increasing so much, so it's not as accelerating as much. So we mentioned that about when we're in a car, for instance, if your speed increases dramatically, you really are accelerating, aren't you? Or when you stop increasing your speed so much, your acceleration slows down, right? And here then, of course, the velocity is decreasing, it's going down, which means he's decelerating, okay? Because his velocity is decreasing, so we're decelerating them. But here they want the acceleration at 1.5. We're interested in the slope, so in order to work out the acceleration, we've got to look at the gradient, okay, the slope at 1.5. So to do that, we need a tangent. There's 1.5 here, and we're going to draw a tangent. Now be careful with the tangent when you draw that. It's got to go in sort of the way the curve is going. So you spend some time with your ruler, line it up so that it's going in the same direction as that curve there. So it meets at that point. And then we can draw a triangle, right? We can draw a triangle. Now when you draw a triangle, you need to pick two sort of nice points, okay? 2 points that we're able to calculate with. So if I choose this point here and this point here, okay, and then we'll draw a triangle, okay, and if we look at that drop there, that's going from 10 to 7, so that's 3, and if we look at here, that's going from 1.5 to 4.5, so that's also 3, I think, yeah, okay, so the scales are different, aren't they? So it's going up in 2s there. So yeah, we're going from 1.5 to 4.5, so that's 3, and yeah, and up 3. So then to get the acceleration, you do the vertical divided by horizontal. Vertical divided by horizontal, 3 divided by 3, so that'll be 1, okay? Sometimes they ask create the units then. Look at the velocity units, it's a bit like that, meters per second, but it's meters per second squared, so it's important that you put the little 2 there. Use the trapezium ruler with ordinates t equals 0, 3, 6, 9 to estimate the distance travelled by the particle. Remember, distance is the area, ordinates are these, so in other words, you draw trapeziums 3, 6, and 9, and 0. So there's your trapeziums, you're only going to have 3, okay? Because the ordinates. So it's 3 trapeziums. Okay, so call this then 1, 2, 3, so area 1, so again using your trapezium, it'd be half 0 plus 8 there, times then the distance between them, which is 3, so you work that out, half times 8 is 4, times 3 is 12, area 2 then, that'll be half, that side is 8, this side is 5 times 3, so that'll be 6.5 times 3, which is 19.5, and area 3, half, that height there is 5, that height there is 0, times 3, so 2.5 times 3 is 7.5, and all you need to do then is add these up to get your total distance. So I've got there 39.0, okay, and that's in meters, so that's the distance there. I think I've added that up right, or have I made a mistake? 10, 0, 1, 11, 18 plus the 1 is 19, yeah, I think that's right. So if we look at this then, by considering the graph given, state how you would improve on the estimates for the distance the particles travel during the experiment. So looking at the graph here, we consider the graph, how could you improve on the estimate of the distance? Well, if you look at the trapeziums here, okay, they're quite wide, aren't they? The height is quite wide there. If we narrowed this, so if we had more trapeziums, If we had more trapeziums, then it would be slightly more accurate, because if we had more trapeziums, there would be one there maybe and one here, and we could that bit of area there that hasn't worked out, we could actually work it out now without trapeziums. Okay, we could work it out if we had more trapeziums, and especially this one here, you can see there's a lot of area here that hasn't worked out. But if I had a trapezium there, I could actually then work out a closer approximation. So what we could say is we need more ordinates, because that's the word they use there. Okay, more ordinate needed, or if you prefer, you could just say, look, reduce the height of trapeziums. Okay, so you could say that.